Your current chatbot project is failing because you're treating a powerful engine like a simple script.
You call models through basic code and get inconsistent, frustrating results, leaving you guessing at how to make them reliable.
This is the core struggle of the AI engineer. Imagine you are a head chef in a restaurant kitchen.
Right now, you have one single basic stove, your LLM API.
You are manually cooking every order by hand, and it is exhausting.
You need a real kitchen with proper stations to handle professional service.
We are going to build that kitchen together, one layer at a time, until you are ready for production.
Are you ready to stop guessing and start building?
Your chatbot acts erratic, ignores instructions, and gives inconsistent answers because it lacks clear guidance.
We need to define exactly how the chef should behave.
We install a recipe book right next to the stove.
In our world, this is a system prompt.
It is the set of hidden instructions that define the model's persona and rules.
Without this, the chef throws ingredients at the wall and hopes for the best.
With a real recipe book, the chef follows your exact standards for every single order.
It transforms your erratic script into a predictable service.
The recipe book helps, but the chef still has to memorize the entire menu to keep up with the rush.
Even with a great recipe, the chef eventually runs out of desk space to hold all the ingredients.
This is the challenge of LLM fundamentals.
Your model has a strict limit on how much text it can process at once.
We call this the context window. Think of it as the size of the countertop in your kitchen.
If you try to pile too many ingredients on the counter, the chef starts losing track of earlier steps.
They forget the recipe book instructions because there is no room left to work.
You have to manage your tokens carefully to keep the counter clear.
The counter is full, but we need to access an entire library of company data to answer the complex questions our customers are asking.
Your chef cannot memorize the entire company manual, so we need a way to look things up on the fly.
We build a pantry. We call this architecture RAG, or Retrieval Augmented Generation.
We take our raw data and turn it into embeddings.
These are lists of numbers that capture the meaning of the text.
We store them in a vector database.
Now, when a customer asks a question, we search the pantry for the most relevant ingredients.
We pull those out and place them on the counter.
The chef reads the manual page and answers the question accurately.
The chef can find ingredients, but they still cannot perform complex, multi-step tasks like calling a supplier or updating a ledger for us.
How do we turn a question into a search query that finds the right ingredient in that massive pantry?
The first search pass might bring back items that are close but not quite right.
We need an ingredient sorter. This is what we call re-ranking.
We take those top results and run them through a more powerful, specialized model.
It looks at the context and decides which one is the absolute best match for the customer's request.
It is like a quality check before the chef starts cooking.
It ensures the information we feed the model is actually useful.
The pantry is built, but finding the right item is still tricky if the search is not precise enough for our needs.
A chef is great, but what if they need to call a supplier, check inventory, or update a ledger?
We need to hire a sous chef. In our architecture, these are agents and tool use.
You give the agent a high-level goal and it decides which tools to pick up.
It can reach out to an API, use a calculator, or query a database.
It's not just generating text anymore, it is performing actions in the real world.
It makes decisions based on the task at hand.
The sous chef is powerful, but how do we keep track of their work?
We need to make sure they are following the right process and not just guessing at what to do next.
How does the sous chef decide which tool to pick and when to stop?
We use a pattern called REACT. It stands for reasoning and acting.
It's the sous chef's internal monologue.
The agent thinks about the goal, decides on an action, and then observes the result.
If the result is not what it expected, it thinks again and tries a different tool.
It's a real iterative loop that keeps the agent on track.
It is how we move from simple chatbot responses to reliable, autonomous task execution. The sous chef is hired, but we need to define their process clearly.
If they make a mistake, we need to know exactly where the logic failed so we can fix it quickly.
When the sous chef messes up an order, you have no idea why because the process is a black box.
We need to install an inspection desk. This is evals and observability.
We add cameras and logbooks to track every single move the chef and sous chef make.
We can see exactly what tools they used, what data they retrieved, and where the reasoning loop went off the rails.
It gives us the transparency we need to debug our system.
Without this, we are flying blind every time we deploy a new update.
We can see the logs, but how do we know if the output is actually good?
We need a way to measure the quality of the final dishes automatically.
You have logs, but you are still manually checking every single dish to see if it meets the standard. We need a quality suite. This is the evals part of our observability layer.
We create standardized tests that automatically grade every dish before it leaves the kitchen.
If the chef produces a bad result, the system flags it immediately.
It's the only way to scale our service without hiring 1,000 people to watch the output.
We have a fully equipped kitchen now, but what is the final piece of the puzzle?
We have all the stations, but we need someone to manage the whole operation and ensure it stays profitable and consistent under pressure.
Your kitchen is fully stocked, but it is still running as a prototype, not a professional service.
We need a manager. This is production ops.
The manager ensures the kitchen stays open, the staff is trained, and the service is consistent under pressure.
We now have a fully equipped kitchen with a recipe book, a pantry, a sous chef, inspection cameras, and a quality control suite.
The only thing missing is the final polish of production scale reliability.
The kitchen is built, but how do we ensure it stays profitable and reliable?
We have to look at the costs and the speed of our service to make sure we are actually delivering value to our users every single day.
Take a look at your kitchen. It has come a long way from a single stove.
We have installed 7 distinct stations. We have the prompting station for our recipe book.
We have the context window for our workspace.
We have the pantry for our rag retrieval.
We have the tooling station for our agents.
We have the inspection desk for observability. We have the quality control suite for our evals.
And we have the manager for our production operations.
You are an architect now. You are not just calling APIs anymore. You are building a complete, reliable system.
But even with all these stations, we still face the fundamental trade-offs of the real world.
We have to balance our speed with our quality.
Your kitchen is perfect, but it is slow.
Every extra station adds time to the order.
This is the latency versus quality trade-off. When you add RAG or complex agent logic, you are adding steps to the process.
Each step takes time. If you use a massive model to get the highest quality, your service speed drops. You have to decide what your users actually need.
Do they need a perfect answer in 10 seconds or a good enough answer in 2? You cannot have both at the same time.
You have to optimize for the specific needs of your application.
Speed is a problem, but what about the cost?
A professional kitchen is expensive to run every single day.
A professional kitchen is expensive to run. Every ingredient and every staff hour costs money.
This is cost versus performance. You're paying for every token the model generates.
If you use the most powerful models for every simple task, your budget will disappear.
You need to balance the cost of your ingredients with the price of the dish.
Sometimes a smaller, cheaper model is perfectly fine for the job.
You have to be smart about how you use your resources.
Costs are managed, but what if the output is wrong?
Even the best kitchen has bad days.
Sometimes the chef just gets it wrong and serves a dish that is completely unacceptable to the customer.
Even the best kitchen has bad days. Sometimes the chef just gets it wrong.
In AI, we call this hallucination. The model confidently generates false information.
It looks like a real answer, but it is completely wrong.
It's like serving a dish that looks like food but is actually made of plastic.
We need a way to catch these errors before they reach the customer.
We cannot stop the chef from having bad days, but we can stop them from serving the bad dish.
It is a reality of working with non-deterministic systems.
Failure is inevitable, but how do we prevent it?
We need to build a defensive architecture that wraps our AI in safety at every single step.
We cannot stop the chef from having bad days, but we can stop them from serving the bad dish.
We build a safety net. These are guardrails.
They are a real check before the dish leaves the kitchen. If the output does not meet our safety standards, the system blocks it and tries again.
It is defensive programming for the AI era.
You must assume the model will fail and build your system to handle it gracefully.
Safety is not an afterthought. It must be built into the architecture from day one.
Safety is in place, but how do we keep the kitchen modern?
The field is moving fast, and we need to stay ahead of the curve.
The kitchen is changing. We do not always need a master chef for every single task.
We're seeing a shift towards smaller, specialized models.
It's like hiring a pastry chef for desserts instead of asking the master chef to do everything.
These specialized stations are more efficient and often perform better for specific tasks.
You do not need a giant model for every request. You need the right tool for the job.
Specialization is the key to scaling your application effectively.
The future is about smaller, smarter, and more focused systems.
Specialization is coming, but how do we stay ahead?
You have the skills to build this. You are not just a coder, you are an AI architect.
You have the skills to build this. You are not just a coder. You are an AI architect.
Your background in APIs, databases, and software lifecycles is the perfect foundation.
You already know how to build systems that scale.
So now you're just adding AI to your toolkit.
Take pride in the kitchen you've built.
You can serve any dish now. You are ready to take on the most complex problems in the industry.
You do not need a PhD in machine learning to be a great AI engineer.
You just need to understand how to assemble these pieces into a reliable service.
You're ready, but what is the first step?
Don't try to build the kitchen at once.
Do not try to build the whole kitchen at once.
Start with the stove. Get comfortable with simple API calls and basic prompting.
Master the fundamentals before you add the pantry or the sous chef.
Iterate as you go. Build one station, test it, and then move to the next.
You'll learn more by building a simple, working application than by reading about complex agentic frameworks.
Start small. Focus on one specific problem you can solve for your users.
Once that works, expand your kitchen. You are not alone in this journey.
There's a massive community of developers building the same tools.
You can learn from them and contribute back to the ecosystem as you grow your skills.
You're not alone in this kitchen. There is a whole community building the same tools.
It's like a professional association where chefs share recipes and equipment.
Use the open source frameworks that everyone else is using.
From your basic fuel content to electrical and mechanism powering, you can customize your operation on a massive scale. The community has already solved many of the problems you are facing today.
Leverage their work to move faster. Collaborate to innovate.
You'll find that the best AI engineers are the ones who share their knowledge and build on top of what others have created.
You have the tools, you have the community, and you have the vision. What are you going to cook? Your kitchen is ready for your first production application.
Your kitchen is ready. What are you going to cook?
Serving the final dish is the best part of the job.
It's your first production AI application.
It is the moment when all your hard work comes together to solve a real problem for a real user.
Don't be afraid to fail. Every dish is a learning experience.
Every error is a chance to improve your kitchen.
The journey is just beginning. You have the skills to build amazing things.
Go out there and build something that matters.
You are an AI engineer now. You have the architecture, the tools, and the mindset to succeed.
I cannot wait to see what you create. Go build something amazing today.
Thanks for joining me in the kitchen today. Keep building, keep iterating, and do not forget to test your dishes.
We have built a full kitchen, learned the 7 layers, and seen the trade-offs.
You're ready to start your own AI engineering journey.
If you found this roadmap helpful, make sure to like, follow, and subscribe for more videos like these.
And comment down below what you want to learn about next.
We are always adding new stations to our kitchen, and I want to know what you are building.
It's time to close the kitchen for the night, but your work is just starting.
Go build something great. I will see you in the next video.